So again, the remove method, just like the add method, is essentially 3 parts. You have 3 cases, and they happen to be pretty much exactly the same as the add method. So public remove int index, right? I want to remove an item at some index. Let's go ahead and quash it error, return null. Let's also not forget to do size minus minus. Very important there. Pretty much just important. So what are our 3 cases? Well, let's go ahead and just extrapolate from the first from here. Checking to make sure I can actually remove the thing I'm going to do. I'm going to remove. Index at it, making sure it's a valid index. Then, well, this was adding a new head, so removing the new head. And that makes sense, right? The reason this is a separate case is because the head changed over here, so we needed to update that. Similarly, with remove, if we're removing the head, we need to update the head to be the new head. And then adding anywhere else also makes sense. That was another case, so that will be removing anywhere else. So our 3 cases here are index out of bounds, removing the head, removing anywhere else. Okay, so we've got those 3 cases. So let's go ahead and program the first one. And that's easy enough. We're just going to grab this over here. Well, we'll grab this over here and change it to greater than or equal to size. If it's less than 0 or it's greater than or equal to size, right? If it's not an index I can remove, then it's out of bounds. So we're done there. Okay. Next. What is next? Our next objective is we need to look at removing the head. So how would that work? Well, if I am removing the head, if this needs to go by, then this guy needs to be the head. Right? That makes sense to everybody? If we're moving this first, if we're getting rid of this, if this is our starting point and we want to remove the head, then this needs to be our ending point. Okay? So the question is, how do we get there? Oh, and I do need to return the data that's in there. So let's look at, so let's go ahead and go E to return. And that will be, and we will go ahead and say to return over here. Set equal to null so that we quash that error. So if index equals 0, we want to remove the head. So really, all we have to do is, if we think about it, just move this to go over here, and then garbage collection will come in and take care of the rest for us. It will just go ahead and go bye. Okay, so all we really need to do is say to return is equal to head.data. Right? Store that data so that I can give it back to the user. And then head is equal to head.next. Head is equal to head.next. The memory location of that is stored in head is going to be equal to the memory location that is stored in head.next. So we're not making a circular thing right over here. We're not making this arrow curve around and point at itself. Not yet, at least. That's for circular linked lists. Instead, what we're doing is that we are saying the memory location of head is going from here to here. Now you might be going, wait, how would I make it circular? How would I make it point on itself? It would be head.next is equal to head. That would make it circular. Right? That would make this point to itself. Right? So head is equal to head.next. Remember, we are modifying what head is. And we are storing, and how are we changing it? We're storing head.next in it instead. So this line will just simply move this over here. And because we're working in Java, we don't actually need to do anything else. Garbage collection will handle the rest for us. All right. That is fairly nice. So now we need an else case. Every other case. We need to do what? Well, in that case, we want to say we want to remove index 2 over here. Okay, say we want to remove index 2. In that case, what we need to do to remove this guy is kind of the same idea. If we want to remove him, then there should just be one arrow, and it should be pointing like this, right? Don't need that arrow anymore. So if we remove this guy, then this is our end state. Okay, so how do we do that? Well, again, just like going with add, we need to modify this arrow over here. We need to modify this .next. So I need to get the node before, like I did before. I need to get before like I did earlier. So before is equal to get node at index -1. And we know that index -1 is never going to go out of bounds. How do we know that? Because we only do index -1 on an index that is greater than, get node, on an index that is greater than 0. So it's going to be at least 1. So perhaps the one before might even be the head. But that's perfectly fine. We also know it's not going to go out of bounds this way because of this restriction over here. So node before is equal to get node. All right, then we need to grab this item over here. So let's go ahead and say this is the node over here we want to remove. So let's go ahead and, again, we need to draw everything. And again, I'm going to just do this with one variable. So that's before. And we don't need this or anything else, right? Because this is somewhere in the middle of a list somewhere. Right? So we get before is equal to before.next. Or we get before. And now this is the target. This is what I have to, it's his data I care about. So to return, I mean, ostensibly, I could say basically that there's a couple ways I could go about this. I could say node target, the guy I want to remove, is equal to get node at index -1, or I could say it's equal to before.next. Now, what I care about is his data over here to return. So I'm going to go ahead and do to return is equal to target dot data. Okay, so I've stored that. Nothing here has changed. But in preparation for the next step, what I am going to do is actually I'm not going to use this variable because target is just before.next. So what I can do instead is put before.next.data, right? To return is going to hold the memory location of before.next.data. Before.next, this is the guy we want to remove in the middle. His data is what I want to return. Before.next, is that before.next.data. Might be more clear if I don't use that arrow and just simply give him a label like that. Before.next and his data. All right. Now let's go ahead and, this is probably even better. So now let's go ahead and how do we remove this? So this is the line where I typically miss people. So I need to get from here to here, right? Where this points to this. Now the intermediate point, if I'm using the garbage collector to get rid of stuff, is that this guy's, if I put this guy down here, again, the physical locations of everybody doesn't matter, is this is the intermediary point. This is the point where if I move this pointer, then the garbage collector will come and eat this guy. So I need to take this arrow, right, and move this arrow over to here. Okay, so that's two questions. First, what is this arrow called? This is before.next. So we're changing before.next what it's going to be pointing at. What are we changing it to? We're pointing at this node over here. So what is this node? What is it in this node in relation to before? Well, this node over here is what? Before.next. So what is this node? It is before.next. If you can wrap your head around this, then you're in good condition. So basically, make sure you can get up to this point, because this is the last line, and this is basically the leap of logic that you have to make. Before.next. This is the before.next. This is the memory location of that that resolves to, and we are storing that in before.next. So this, as a result, now points to this. Assuming I can actually move these things. Got to be really accurate with it. All right. So before.next, this arrow now points to before.next. We take this memory location on the right and store it in this variable on the left. That is how you remove a node in the middle. So let's go ahead and test this out. So we've added our nodes. Now let's go ahead and test list.remove -1, list.remove 5, right? That's fine. Now we're going to go and list.remove. We want to remove index 0 first. This should remove the 0. Would probably be advantageous if I actually printed out what happened. Okay, let's go ahead and remove all the items. Great. Remove index 1. Remove index 2. Remove index 1, and then removed index 2. So that remove method works. So this is a linked list. So in the next video, I'm going to go over why we bothered creating this linked list.